Gentlemen, welcome to practice set 1B video. There's not many questions, there's only 8 questions, so we'll go through this relatively quick. But let us start with number 1. Given the table dt below, what is y? So I give you this table, right? It's called dt, it's named dt, and then I do some code right here, right? I'm doing some selection. Now what's happening here is I am to the left of the main comma, I'm using the grep function. Remember, the grep function basically is checking to see if there's any values, chocolate in this case, in the phrase column, right? It's checking to see if there's any values chocolate in the phrase column. So the whole column does not have to be chocolate. It just has to be, there has to be any word in there has to be chocolate. So in this case, right, and again, this is just for filtering the rows. Remember, the first section of the data table is to filter the rows. In this case, in 3 rows have the word chocolate in it. This one, sorry, the 3rd row, the 4th row, and the 5th row. All right, so what ends up happening here is, I can show you on this sheet right here. Let me zoom in. There we go, zooming in. So remember, we start with this table right here. Just applying this filter changes this table to this table. Oh, cool. Hopefully you guys can see this. All right, this row, milk chocolate. Can I copy this? Milk chocolate. I like dark chocolate. Set a period. And I do not like white chocolate. And I have the value, subsequent amount values, 973. 973. Right, so just from that first part right here, the grep part, it filters that table and I get these rows right here. Now, to those rows, which is right here, this subset, I'm now going to take the summation of the amount column, the summation of this column, which gives me the value 19. And so y just ends up becoming the value 19. So the answer is y is 19. Save this. You go ahead and save this file actually, so I have it for you guys. I'll probably say this at the end, the way this numbers works. Let's export it at the end. So we'll move on to number 2. Number 2, same thing, table question, right? But now, notice how I changed the grep feature. Before above, I've just put grep quotes. Now remember, grep is it's part of the family of regex, gsub. It can take regular expressions. In number 1, all I did was I put a word in quotes, and that's it. I just wanted to scan for that word, right? Be it a standalone word or a word in a sentence, or maybe part of another word, right? It's going to find that chocolate, those letters in that succinct pattern. Now here I'm using, again, the braces system, right? And I'm choosing capital letter A dash Z. Now again, this is slang in the regular expressions world when you're using the braces, right? The open brace and close brace, that I want all the letters, capital letters from A to Z. It's the equivalent if I wrote A, comma, capital B, comma, capital C, comma, etc., 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 all the way to capital Z. That little dash is just a convenience for us. It's convenience. It's shorthand for basically saying all the letters, all the capital letters in the alphabet. Okay, and I'm applying this search in the phrase column. Okay, again, I'm filtering because here's the main comma. To the left of that comma, I'm filtering, right? Now, where in these rows is there a capital letter? The third row has it, and that's it. So if I were to come here and copy this, I could literally just copy that. And what happens is the filter just basically just becomes this one row. And then when I do the second part, sum up the amount in column, when I sum up the amount in column, it's just 9. So the answer is y is basically the answer is going to be 9. Number 3. Yes, function problems. Given the two functions below, we use functions in our lab. Given the two functions below a and b, this a function and this b function, what is b of 5? What is b of 5, okay? So remember, when you're doing functions, each function is a standalone set of code from the other. So when I say what is b of 5, automatically, if you come down here, you'll see, oh, I'm calling the a function within here. See that? Calling the a function within here. So that's fine. That's not a problem, but we should step through it logically. So here what I'm going to do is, I will copy both functions into number just so I have it side by side. And you guys can see how we parse through this. All right, so there's B, let me copy A, and there's A. Right, it's kind of hard to see in this format, but I just have it here, just so I don't have to flip back from side to side. So, and the question starts at what is B of 5? Now remember, we have to slowly go through this. So what is B of 5, right? So B of 5, the parameter of the definition function is y. That means automatically that y is going to equal 5. All right, y now equals 5. So I come here to the first line of B, and now the first condition is saying, hey, is basically if else. So it's saying is a of y, again, what is y? Right above it, it's 5. So it translates into, is a of 5 less than 25? Right? We have to solve this problem. We don't know, right? Because that requires us now to go to this function. Now, I said, what is a of 5 less than 25? So I just immediately, within that function b, another function a is being called. So I go here, and now x is the single parameter of a. That means now x takes on the value of 5. Right? X takes on the value of 5. All right, so what I'll do is I'll shift that over here just so we know we're in the a function now. So the first column here is b function, here is a function. So x equals 5, all right? So x equals 5. And now I go ahead and do the first line. Is x, which is 5, greater than 5? Is 5 greater than 5? Right? No, it's not. Which means we don't do this, we don't execute this line of code, we execute this line of code. We're going to execute y equals 5 times x, and we already said x is 5, so y will equal 5 times 5, which is 25. All right, and then we return y. So y gets, that value 25 gets returned. Where does it get returned? Over here, back over here. A of 5 gave me 25. All right, now this translates into, I will do it down here just so we know that we stepped through this and then we came back here. So this translates into is 25. Because remember, a of 5 became 25. A of 5, when I put 5 in here, return the value 25. So a of 5 is now 25. Is 25 less than 25? No, it's not. So this condition is false. We come down here to x equals y plus 4. X equals y plus 4. And again, what is y right now? Right there, y is 5. So this becomes x equals 5 plus 4, which is 9. So x becomes 9. We're finally here at this point. We return 9. So the answer is 9. B of 5 is the answer 9. All right? That's how you want to do. You want to break it up step by step. So then I come down to number 4. And in number 4, guys, knowing that you probably would need a little more practice on this, I gave you a second question on this. Right, again, let's go down to number 4. Given these two functions again, what is b of 10? Given these two functions again, what is b of 10? All right, so I have these two functions already here. Just copy them. All right, let's scroll up and let's do it. What is b of 10 now, guys? All right, so again, we do it. Go to the b function. What is a single parameter in a b function? Y. So y takes on the value 10. Also, I purposely chose these variables in these functions, this y, that x, this x, that y. I did this so you can see that, look, within these functions, this x belongs to b and is something different than the x in here. This x belongs to that a. So they're completely two different. So these x and y's within this function are completely different than these x and y's in this function. All that matters is what value is passed into those functions. All right, into those functions. That is why, again, we start off with y equals 10 in the b function. We come here and we ask the question. The first if condition is, it's asking, is a of 10 less than 25, right? And again, we have to go to the a function to figure that out. So is a of 10 less than 25? The question is, what is a of 10? So I come here. It's a again has a single parameter x, and that value x takes on the value 10. All right. I come here to the first if condition, and this is basically asking, is 10 greater, is 10 greater than 5, right? Is 10 greater than 5? Yes, the answer is yes, right? 10 is greater than 5, so we go ahead and we execute this set of code, y equals, and not obviously this set of code, so we have execute y equals x minus 5, and again, x is 10, so y is going to equal 10 minus 5, which is 5. All right. We obviously don't do the else part because with if else's we only do one or the other part. We don't do both, one or the other. Totally skip this part. I come down here, return y. Y is a value 5. So the value 5 gets returned. The value 5 gets returned when we call a of 10. Right? When we call a of 10, the value 5 gets returned. So now we come back here, and now this line of code turns into, we simplify that too, because a of 10 returns a 5. This turns into, is 5 less than 25? Right? Is 5 less than 25? Yes, the answer is yes. Oops. The answer is yes, right? And because that's yes, we now come here and we now execute x equals 2 times y. What is y? It's not 5, guys. That was in the A world. Remember, this is why I kept the separate columns. You come up here, what is y right now? Y is 10. Y is 10. In the B function, y is 10. This was in the A function. In the A function, y became 5, and we returned that value. right? And we return that value, but the variable y within the b function is still 10. And this is why x ends up becoming 2 times y, and this is why x becomes 20. And then here in the code, we return x, so the answer is 20. b of 10 returns the value 20. All right, so this becomes, the answer is 20. Number 5. Number 5, given this table DTA below. All right, so this table right here with these columns is the table DTA. What is y given the code? Okay, so here we have a vector, and then we have a for loop. We have something happening within the for loop, and then we have some math happening. All right, so let's go ahead and do this. So VV becomes jam, mint, car. So first things first, let's go ahead and copy. I said copy. Let's see if we can copy this table. Oh, it doesn't look like we can copy it. Let's try it. So no, you can't copy it. Somebody's write it down real quick. Food value. And the food is caramel and mango. Jam and salt. Peach. All right, and the values are 5297341. 5297431. 5297341. 7341. Excellent. 5297341. Excellent. Let me just fix this. This is a, and this is lowercase as well, and salt is lowercase. Excellent. So we have our 2 columns. All right. This table is called DTA. This table is called DTA. Now we can do the rest of the code. In the rest of the code now, we have a vector called VV that's going to be jam, mint, and car. So VV will have the values jam, mint, and car, right? All right, and now we have this for loop, this code right here. Copy that right there. All right, very straightforward. All right, so for I in VV, I got a for loop, and I'm looping through the values VV. Right off the bat, I know I'm going to have 3 loops. There's just 3 items in VV, which means I'm going to loop 3 times. So let's go ahead and do that. Loop 1. All right, loop 1. I takes on the value jam. It's a lowercase I. This is going to keep doing that. So I equals jam, all right? And then I go to the first line of code. DTA bracket I equal food, comma, value colon equals 10. All right, now look what happens. I equals food. What is I? Jam. Where is the value jam going to equal food? I mean, so it's kind of reversed, right? But it should be like food equal I, or I equal food. It doesn't really matter. But we're trying to say basically is in this column food, which values are equivalent to the value in I. In this case, the value in I is jam. So I come here, and there's only one. There's only one row right here. So this whole thing filters DTA for this one row. And then within that row, I'd say I'm using the colon equals. Colon equals is, again, only for data tables, and that is how we create new columns or change existing ones. So we're basically saying, all right, select this row and change the value column to be now 10. So I come here, and this value now becomes from 7 to 10, right? And see the squiggly brace? We're still not done. So that's it. So that's what happens after loop. Loop 1, gem gets changed to 10. Now we go into loop 2. Loop 2, I now equals mint. All right, I equals mint, and now we execute this line of code. Now look what happens again. Where is food equivalent to mint? Right? In fact, I should write that down. Just so there's no confusion. So here I became where jam was equivalent to food. And here where mint is equivalent to food as well. So basically I come here to the food column and I find where in this food column is the value mint right here. Okay, I selected that row. Now the second part, value colon equals 10, again, I'm changing the value column in that row to 10. So now this mint becomes 10. All right. And finally, I have one more loop, loop 3. To make things easier, I'll just copy and paste this whole thing. All right, and in loop 3, I now takes on the value car. All right, and just like before, I equals food. I, in this case, is car. Car equals food. Value is going to be colon equals 10. So again, we come here. Where is the values in food car? Right here. This row gets selected. And in that row, value is going to be changed to 10. Change to 10. And I'm done with the for loop. I'm done with the for loop, and now I come to this part where I simply say, take the DTA table, comma. Notice next to the comma, to the left of the comma, again, there's nothing there. ABI students, remember, that means we're selecting all the rows. There's no filter. We're selecting all the rows. And for all the rows in this table, sum up the value columns. So basically, sum up all these values and put that in Y. So Y ends up becoming, the answer in this case is, the sum is going to be 46. So the answer is Y now becomes 46. All right. Number 6. Let's go down to number 6. All right, so now we come down to number 6, guys. Number 6, again, it's the same table question with a slight change. So let me do this again. Let me go ahead and grab this table. Let me obviously fix the values to what they were before. 5297341, 52973, 5297341, 5297341. All right, and again, I'm going to do VV gem and car. All right, so let me grab the VV. I got that right there. That's the same. And let me grab this for loop and this code right here. All right, there you go. So again, I have a for loop that's iterating through VV. That means I have 3 loops, guys. So let me do loop 1. Loop 1. I, again, will be jam. Come here now. DTA, I equals food. So again, we've done something like this before. This becomes basically jam. Just like the previous question. Jam equals food. I come here. Oh, add a column before. Perfect. I have to add a column before, guys. You guys will see why. All right, I come here. Jam equals food. Okay, excellent. That's this row right here. And now I'm saying, hey, price colon equals 10. To the price column, give the value 10. There is no price column. That's okay. Remember, colon equals within the data table. It changes values in a column or it creates new columns. So what ends up happening in this first loop, a new column price is created. And for this row that we selected, where the food value in food equals jam, which is this row, right? There's going to be the price for this new column that gets dynamically created becomes 10. All right, it all becomes 10, and the rest of these guys by default become NA, 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 NA. Boom. See that? Just like that. Bam. That's what this happens here. All right, and we're done with that loop. Now we will continue to the next loop. Loop 2. I now equals what? I now equals the value mint. All right, I now equals the value mint. So I come here, this now becomes DTA mint equals food. Come here, highlight this row, and now the price is going to be changed to 10. All right, so this value now becomes 10. I come to loop 3. I now takes on the value car. Come down here. This now becomes car. Find the row where food equals car right there. This is the row we select. And to that row, price gets value changed to 10. And now we're done with the for loop. And now we finally come down to this line right here. And again, look, there's a comma. To the left of it, there's nothing. That means we're selecting all the rows. And to all the rows, I'm saying sum up price, but the sum function, I'm doing something funky. I'm summing up the price column, but I added a comma in this additional parameter, na.rm equals t. What this is basically saying is, if I were to simply just do sum price, because there's an na in there, right? Just one. I just need one. The sum of the whole column would give me the value na. Anytime you do math with any set of data and there's just one NA in it, everything, the result becomes NA. So what this does is this goes the extra step and says NA.rm equals T, basically remove the T's, remove the NAs, and then add up the number. So what ends up happening here is the sum function pretty much just ignores the NAs and adds up these 10s, and I get the answer 30. Equivalently, the other way I could have done this, so the answer here is 30. All right. Equivalently, the other way I could have wrote this is I could have just basically wrote and said y equals, let me write down alternative syntax, right? Could have been basically, I could have done basically y equals dta, right? Exclamation point is .na, price column, comma, sum price, right? What is this saying? Again, to the left of the column, comma now, I'm filtering the rows for where exclamation point means not or opposite of. So if I say is.na, comma, parenthesis, price, that's basically saying, hey, is this value an NA, right? So if I didn't have the exclamation point, what basically it would do is it would filter for all the NAs in the price column. It would give me this row, this row, this row, and this row. When I put the exclamation point in there, it's saying basically, hey, are you not an NA? So then that gives me this row, and this row, just because I put the exclamation point there. When I remove the exclamation points, then it would give me this row, this row, this row, and this row, which is not what we want. We want the other one. That's why I put the exclamation point in there. Equivalently, there's another function you could use, another syntax, right? When you're dealing with numbers, and this function comes in very handy when you're doing fancy calculations, and this is called is.finite, right? Because when you're doing math, it's possible, depending on the numbers you're using or the calculations you're doing or the inconsistency of the data, you get infinite. You do wrong math, like you divide by 0 or you divide by 0 by a number, right? And that gives you like infinity, or you could just have NAs, right? So what is.finite does basically, it says, hey, in the price column, it basically says, hey, are you a finite number? Are you a finite number? No. No. Yes. Yes. No. No. So basically, that's another way to filter for actual numbers. So then this will give me, again, this row, this row, this row, and then I would add up those values, and again, the answer would be 30. So these are the alternative syntaxes right here for you guys, in case you were interested and you were wondering. All right, number 7. And number 7, we finally are using we'll get to the mapply part, and this is the big unveil that I did to you guys when we were doing the lab 1B. I showed you guys this new feature called mapply that you use in conjunction with a function. Oh, that rhymes, conjunction function. Right, so basically we have this function. So given the code below, what is y, right? Given this code below, what is y, right? So mapply, I'll show you do it by hand, but then I'll show you in the R code how it works as well, right? So what mapply does is, again, any function and parameter and vector or set of parameters you give it, right? It will take every value in that vector or set of values and send it to the function, process the function, and get the results, right? And store them whatever's to the left of the mapply. In this case, m is serving that purpose. So here I have the simple function from the previous problems. I just took the A1, all right? And let's go ahead and do this. So for number 7, here is the function. And here is subsequent code afterwards. Put that right down there. All right. So here's the code. Here's the function. Now, the function is pretty straightforward, right? Takes a single parameter, check to see if it's greater than 5, then we apply whatever math we need to, and return y. What is xx here in this case in this code? Xs, well, I don't think you guys have seen this explicitly. My ABI students, you should remember this from ABI. For those who new to R, what seq stands for, it's one of these nifty little functions that R gives you, just like in Python, to create like alternate ways to create vectors of numbers in a very convenient way. In this case, seq stands for sequence. And the 3 parameters here basically stand for the number this sequence is going to start with, right? The number is going to stop at. It's going to start at 2, stop at 10. And then this third parameter basically says in how many steps from one number to another. So in this case, because it's stepping by 2, and we're starting at 2, xx, first value will be 2. The next value will be 2 plus that, which is 4. Next value will be 2 plus that, which is 6. Next value will be 2 plus that, which is 8. And the next value after that will be 2 plus that, which is 10. Right? And we stop at 10 because the second parameter tells us when we stop. And the value we stop at is 10. And so there you go. XS becomes 2, 4, 6, 8, 10. Now this vector will be in the mapply right here, the next line. Mapply, notice the first parameter is the name of the function, right? In this case, it's this function A. The second parameter is the second and ongoing parameters basically after that are going to be basically the vectors that represent the values you're passing in to the parameter. Now in this case, A has just one parameter, so this is why there's only one vector right after it, and with the values 2, 4, 6, 8, 10, and those values will be passed on to mapply. Now because there's 5 values, how many times will the A function be called, guys? It will be called 5 times. It'll be called 5 times for each one of these values. And that's how the mapply works. The mapply is very similar to basically a for loop. And a lot of times you might ask, okay, why use the mapply over for loop? One, mapply is a little bit faster. Two, it takes care of the whole data container issue, right? When it comes to a for loop, you have to remember in our lab, in the previous problems, we would run a for loop, and then we would store the values in the vector table. mapply pretty much takes care of all that and returns the output for you. Or if you don't have an explicit output, it just updates the tables for you, right? And you'll see that in the next question. So we're going to have, I don't want to call these loops because we're now looping. I want to call this, I'll literally just call it first value, second value, third, fourth value, fifth value. So I say value 1. I'll just put the number in there. So value, we'll say value 2. All right, so value 2 is up first. It gets passed into the function. All right, and I'll explicitly do it for you. So x becomes 2 in the A function. Is 2 greater than 5? The answer is no. Right? It's no, so we go ahead and we skip whatever is in this initial braces and we'll go to the else part. Therefore, y will then end up equaling 5 times x, which is what? 2 lines above it, it's 2. Right? So y equals 10. All right? So the first value, this just happened to be, perfect, right here. The first value in M, the vector M, we'll keep that track of that up here, becomes 10. Right there. Right? The first value after value 2 becomes 10. Now we go to the next value, which is 4. Value 4. All right, so that's passed into A. We do it again. X equals 4. Is 4 greater than 5? Nope. So again then, we go ahead to the bottom part, y 5 times x, which is going to be 4. So y will equal 5 times 4. So y becomes 20. We return the value y, which is 20. That value gets returned. And now, this is what I was talking about with mapply. mapply takes care of the data containers and the outputs, all that stuff for you. So y gets outputted, which is value 20. So in M, we now get the next value, which is 20. We now go into value 6. All right. X6 greater than 5. Yes, 6 is greater than 5. So now we do the first part, y equals x minus 5. Or in this case, it's going to be y equals 6 minus 5. Y equals 1. 1 gets outputted. And now this becomes M 10, 21. Next value is 8. X equals 8 is 8 greater than 5. Yes. Come here. All right. What is y now? So is 8 greater than 5? We come here. We do the first one again. Y equals x minus 5. Y equals 8 minus 5. Y equals 3. Right? And then now this, I'm sorry. I didn't mean to do that. we just want to keep track of one vector. So third value here became 1. Fourth value became 3. Expand this out a little bit. And now we're on the final value, which is 10. Value is now 10. X equals 10 is 10 greater than 5. Yes. Y then equals, because that's true, we do the first equation. Y equals 10 minus 5. So y equals 5. Right, and then we're done with the m-apply. The m-apply is done, and now m has these values 10, 20, 1, 3, and 5. All right, and we come down here and we say y equals the sum of m. So what does y end up equaling, guys? Y ends up equaling, let me get the answer down here. Y ends up equaling 39. And that's our answer, 39. See? Very easy. The answer was 39. And let's go ahead and check this. I want to actually show you guys this in R. And let me copy this. Hopefully it won't cause too many problems. Nice. All right, excellent. And now I'm going to do XX, right? And see, there's XX right there. There's the A function right there. Excellent. Actually, let's clean this up a little bit. Oops, I know I'm going to get an error here. Guys, remember, anywhere where you have a minus and you copy and paste, it's not a minus, so this is going to give you an error. So there, I deleted this, created a real one. Let me rerun this. All right. XX over here is good to go. And now I'm going to do my m-apply. Boom. All right, type in m. And you're, oh, yeah. Sorry, guys. We have a slight error in my function. It's y equals x minus 5. I think I deleted the x somehow. Apologies. So let's go ahead and rerun this. All right, now I can go back and rerun this. Now we can look at m. And now we have the value 10, 20, 1, 3, 5, like we are supposed to have. Now I go ahead and run y. And of course, y is going to be 39. That easy, guys. That easy. All right, and leads us to our final question, number 8. Again, it's a skinny practice set. Given the table, DTA, and code below, what is y? Now we're using m-apply again with a slight twist. So let me go ahead and copy this table. Thankfully, it's the table from before, so I will go up here and copy this. This is my number 8. All right, again, 5297341. And here's my code, here's my function. Here's the vector I want to run through that function. I called m-apply, and now I actually want to do some little math, little mathy math there. All right, so let me copy and paste this. Okay, expand this out, and that looks much better. Scroll that over there, and move that over here. Delete this part. All right, and that's your function right here. All right, now this is more akin to the function we used in our lab, because in the lab we didn't really care about our output. What we cared about was manipulating the tables within the function as we were running the for loop, right? So this is more similar to that. All right, so this, hopefully you'll see this similarity to what we did in the lab right here. So again, what I want to do is I'm going to apply this function, and I'm apply to this function ex and p. I'm applying the vector vv. Now vv is pretty, that vector pretty much stands for itself. You guys know it's 4 values: salt, peach, mint, mango. So again, mapply in this case is going to run 4 times. So for the value, let's go ahead and just jump into it. For the value salt, right, we're going to run this line of code right here pretty much, and then return 1. So I'll keep track of the vector m over here. Not that it really matters in this case, but still, right, just so you guys can see it. So I go ahead and I execute this line of code when value is salt. All right, so for values, this is going to be kind of tricky. All right, now I can fit everything. All right, so value equals salt. So what is food equals x in this case? So the parameter here is x. In the first value, salt is passed to x, so x becomes salt. All right, so I go here. In the function, it finds the table, in this case I think it's DTA, right? Yes, this table is DTA. It finds the table DTA, finds the row salt, and here it is, and it changes its value to 1. This is now changed to 1. We're done there, and then the number 1 is just returned. Sorry, this is, shouldn't be a space there. All right, excellent. Good. Oh, there's a space there. No, there's not a space there. It's just showing it like that. So there's no space between the parenthesis and return, by the way. That's, you're gonna get a typo. There's no space. All right. And then 1 is returned. So I come here. Bam, there's a 1 there now. We go to the next value. Value is now peach. And just like before, I'm going to take this, right? Wherever there's an X, that gets replaced by peach. And this line of code is now executed. I come here, I find where I have peach right here. That value's changed to 1. Oh, it's already 1. Perfect. Nothing happens, or just 1 gets overwritten to be 1, no biggie. And then we return a 1 over here again. Come here, and now has the value 1. All right, now we go here and do value mint. Just like before, this becomes, X becomes mint. Search for mint right here. Change that value to 1. Excellent. This gets outputted to be 1 as well. And finally, lastly, value mango. Copy and paste. This value now equals mango. And that, we execute that line of code. So we come here, find the row that has mango, change that value to 1. All right, output the return 1 right here. And we're done with the mapply. After done with mapply, we got this value, this m value, with the value is 1, 1, 1, 1. All right, and now I'm going to go ahead and do the last part, which is basically y equals sum of, I don't know why I did it like this, but y equals sum of the DTA bracket bracket. I could have done it multiple. I could have done it. I'll show you the other syntax right now, but I did sum parentheses DTA bracket comma value. Within the sum function, I'm calling the DTA table, right? And I'm calling, here's a bracket, open bracket, close bracket. To the left of the comma, it's blank, meaning all the rows. And to all the rows, I'm just going to add up. I'm going to not add up, I'm going to take all the value column values, which is this. These values are then taken, and now they're passed to the outer sum function. See, you've been seeing me use the inner sum function, but now they're passed to the outer sum function, which is fine. And so the summation of these values becomes 18. So the answer becomes 18, right? And again, the other syntax I could have wrote this was, I could have done y equals DTA, all the rows, sum value, right? And this would have gave me the same answer. As opposed to calling sum on the outside, I'm doing sum on the inside. But either way, we get vectors from value. That's why it gives us the same answer. So the answer becomes 18, right? And again, let me show you guys here. In R, this requires me to do a little bit of work here. Oops. So what is this column? Food. So food equals C. Wrap these guys in quotes. And here we go. I have my food vector. So remember, I make the food vector first. Then I go ahead and make the value vector, which is going to be 5297341. Five two nine 7341. Right, and then I create the table DTA. Right, there you go. I got this table now. Now I'm going to go ahead and create this function. Clean that up a little bit. And again, remember, return. Boom. And now I'm going to run my oh yeah, I got to create my BV vector. Let's grab all these right here. And as you can see, when I copy and paste, my quotes get all messed up, so I have to fix this. Run that, run this, and now if you type in M, you'll see it's all one. And look, guys, you'll see it's all one. In addition to that, it literally gave us little the little labels for which one it is. Oh, they're like, oh, it's salt one was. It gave you the values with it. It said, oh, okay, salt gave you 1, peach gave you 1, mint gave you 1, mango gave you 1. Pretty nifty, right? And if we look at the DTA table now, right, you can see that the table literally becomes, right here, 521,711, 521,711, 71111, 71111, right? 521,71111. Go ahead, execute this, and y obviously will be 18. All right, 18. And that's it, guys. It's that simple, that straightforward. Hopefully it was just as easy for you guys. If you have any questions, again, reach out to me. All right, this concludes our video for practice set 1B, and I'll see you guys at the next video for practice for lab 1C, where we actually get into the math a little bit for the regression and classification trees. All right, guys, have a great day. Bye-bye. Oh, also, and I'll save this for you.